We're going to graph the inequality listed below. The first thing we're going to do is we're going to find the domain of this because we want to find out where it lies. The domain is solely based on what x values can be plugged in and what x values cannot be plugged in. We know that in this case, the square root is going to impact the domain. You also know that in order for the domain to be a real number, what's under the square root must be positive. So another way that we can say this is we can say that value under the square root, which is x minus 3, has to be greater than or equal to 0. All this is saying is that this value has to be positive. It cannot be negative or else we get imaginary solutions, and this is not what we're looking for. We're looking for real solutions. So our domain is restricted when we solve it. We add 3 to both sides to x is greater than or equal to 3. I want to go ahead and mark that line right now just so I know where this exists. Know that your lowest x value is 3. If we plug 3 back into this equation for x, we would get y is equal to 4. So a point on this graph, and more specifically, the starting point is going to be at 3, 4. And when you plug this into your graphing calculator, you'll see that this graph looks somewhat like this. At this point, since it is an inequality, we want to choose a test point. I want to choose a test point that is clearly not on this function and in the domain. So the domain goes this way. So I'm going to pick a point 5, 0. I'm going to take my original inequality and I'm going to plug in 5 as an x value and 0 as a y value. When I simplify, I end up with 4 plus the square root of 2. We know that this is going to be a positive number, and we're saying 0 is greater than a positive number. That is false. So we look at where our test point is, and we say it has to not be included, so the shading has to occur on the other side of the function. Notice this domain restricts it, and that shading ends right there. And that's how you graph an inequality.